Hello everyone, so in this video we will be discussing matrix. Matrix is a rectangular array of numbers which refers to the rows and the columns. So from your sim or self-instructional manual, discussed there was the other types of matrices. So we have here the first one is the row matrix. It is also called a row vector, which has a dimension of 1 by n matrix. And for example, we have here this one. This is a horizontal array of numbers in 1 by n matrix. We also have the column matrix, which is just the inverse of the row matrix, in which it is also an m by 1 matrix, and it is what we call the vertical array of numbers. For the rectangular matrix, it is said to have an equal value of m and n, or an equal value of the rows and the columns. We also have the square matrix, but from the word square, meaning to say the value of the row and the column should be equal. And for the null matrix, we also have this is also referred as zero matrix because all the elements of the matrix are zero and is denoted by the symbol O, is equivalent to the corresponding points or position of our elements in the matrix. We also have the negative of A, which is denoted by the negative sign and then the name of the matrix. So in this case, we have A as the name of our matrix, and is obtained by changing the sign of all the elements. So for example, we have here the matrix A with elements of -5, 2, 1, 0, and -7 and -3. So after we interchange the sign, that is already what we call the negative A. We already interchanged the signs of the elements. So from -5, that will give us the result of +5 because we already interchanged their signs. From +2, that will become -2, and so on and so forth. So that is what we call the negative of A. Now we also have what we call the diagonal matrix, in which this is a square matrix, meaning to say the dimensions of the matrix should be equal, and all the elements except the diagonal elements are zero. So as you can see here, the diagonal elements has the real value, and the other elements aside from the diagonal elements are zeroed out. So similarly, the scalar matrix is also a diagonal matrix. However, scalar matrix, the only difference of scalar matrix with the diagonal matrix is that the diagonal elements of the scalar matrix should be equal, meaning to say if it is 3, meaning to say the rest of the diagonal elements should also be 3. And we also have the equal matrices, which is said to have same size. Their elements should be equal. So for example, we have here the matrices A, B, C, D, and E, and F. So as you can see, A and B is not an equal matrices because from the dimension itself, you can already say that it is not equal. And for the A and C, although they has the same dimension, or they has the same size, however, their elements differ. One of their elements differ. So meaning to say that is already unequal matrices. Now, from as you can see here, the only equal matrices are A and F. Because as you can see, they has the same elements. I mean, they has the same size or dimension. It is a 2 by 2 matrix. A is a 2 by 2 matrix. F is a 2 by 2 matrix. And even the elements are also the same. We have 3, 2, 1, and 1. For this one, we have 3, 2, and 2 divided by 2, that is still equal to 1. So meaning to say this is still equal with this element. And we also have 1. So the only equal matrices here are A and F. Now we also have the transpose of a matrix, in which this is just interchanging the values of the rows and the columns. So for example, we have here the matrices A, B, and C. As you can see from the matrix A, it is a 3 by 2 matrix, in which after you transpose this matrix, it will become to a 2 by 3 matrix. So its its elements inside the matrices are also interchanged, as you can see from the row From 2 and 3 as the first row, it becomes our first column from the transposed matrix. For matrix B naman, we also have this is a 1 by 3 matrix in which after you transpose that one, it becomes a 3 by 1 matrix. For the C, as you can see, this is an equal elements or equal dimension or equal matrix. This is a 3 by 3 matrix. Now, after you transpose that one, that is still a 3 by 3 matrix. However, the result or the values of their matrices should also be interchanged. Now we'll move on to the discussion of the algebra of matrices. Now for matrices, we only have three operations or three basic operations of matrices, which are the addition, subtraction, and multiplication. So in this video, in this next topic, we'll be discussing the operations of matrices in addition, subtraction, and multiplication. So now we will be discussing addition of matrix. So addition of matrix is just following the same process of how we add numbers in conventional way. For addition of matrix, you cannot add matrices if the matrices has different dimension. Meaning to say, if you will add a 3 by 3 matrix, you need to add that one with another 3 by 3 matrix. The dimensions of the first matrix and the second matrix should be equal or should have the same value. Now, in addition of matrix, we will be in programming, we know that this one is our row 0. This one is our row 1. This is our row 2. And similarly, this is our column 0. This is our column 1. And this is our column 2. And the same as the second matrix, this is our row 0, row 1, row 2, column 0, column 1, and column 2. Now in adding matrices, we need to add the row 0, column 0 by the row 0 and column 0 of the second matrix. And following the same process, we'll be adding elements of the same position. So that gives us equivalent to 4 plus 1, and we have the 6 plus 5. We also have 5 plus 4. In the same process, we have 7 plus negative 3, 0 plus negative 1. We have 3 plus 9, and we have negative 6 plus 8 plus 8. We have 2 plus 9, and we have negative 4 plus 2. So we already have this matrix. Now, just to simplify this one, we need to perform the corresponding operations of our matrix. So we have 4 plus 1, that is 5. 6 plus 5, that is 11. We have 5 plus 4, that is 9. 7 plus negative 3, that is positive 4. 0 plus negative 1, that's negative 1. 3 plus 9, that is 12. We have negative 6 plus 8, that is positive 2. And we have 9 plus 2, that is 11. And negative 4 plus 2 is negative 2. So meaning to say, this is already the result of, or this is already the sum of our matrices. Now we will be moving on to the subtraction of matrix. So we have here, subtract the following matrices. We have 5, 7, 4, 5, 3, 2, 6, 2, 4, minus 3, 5, 1, 6, 1, 8, 0, 1, 0. So basically, again, the same process with addition of matrix. It's just that we need to subtract it with each other. So we will again subtract the same position. So we have 5 minus 3. We have 7 minus 5. We have 4 minus 1. We have 5 minus 6. 3 minus 1 and 2 minus 8. And we have 6 minus 0, 2 minus 1, and 4 minus 0. And then again, performing or simplifying the operation, we have 5 minus 3, that is 2. 7 minus 5, that is 2. 4 minus 1, that is 3. 5 minus 6, negative 1. 3 minus 1, 2. 2 minus 8, negative 6. 6 minus 0 is equal to 6. 2 minus 1 is 1. 4 minus 0 is 4. So meaning to say again, this is the difference of our matrices. Now we'll move on to the last topic, which is the multiplication of matrix. So in multiplication of matrix, this is now different than the conventional operation of matrices that we had, like the addition and subtraction. For this one, you need to assess first if the matrices can be multiplied by each other. Now, how can we assess if they can be multiplied by each other? You need to see the dimension of the matrices. So for this one, the first matrix, this is our M1, right? Matrix 1, this is our matrix 2. Now, you need to see the dimension of our M1 and M2. So in M1, the dimension of this one is equivalent to 2 by 3. Again, this is 2 by 3. And for our M2, this is 3 by 2. Meaning to say 3 rows by 2 columns. Now afterwards, how can you assess if they are if they can be multiplied by each other is this one. Meaning to say if the column of our M1 and the row of our M2 is equal or the same, meaning to say you can multiply these matrices. But if the the column of the M1 and the row of the M2 is not equal, if it's not equal, meaning to say you cannot also multiply the matrices. So it's very important that you see first before you proceed with the operations. You need to assess first the matrices if they can be multiplied by each other. Now again, if the inner dimensions are equal, meaning to say they can be multiplied. Now, how to know if what is the resulting dimension of our matrix? The outer part, the outer dimension of our dimension is the resulting this is the resulting dimension of our matrix. So as you can see, row 1 of M1 and column 2 and the column of our M2 is the resulting dimension of our matrix. Meaning to say, a 2 by 3 matrix multiplied by a 3 by 2 matrix will result to a 2 by 2 matrix. Again, our goal here is to find the product of these two matrices in a 2 by 2 dimension. So now let's proceed with the operations. We'll be multiplying this matrix by this matrix. In multiplying this matrix, you need to multiply the first one, the second element, by the second column or the second row, the third column by the third row, and so on and so forth. We have 5 and multiplied by that, this one, and this one. So now we'll do this one first, and then we'll see later on with the other elements. So we have 5 multiplied by negative 1, and then you need to add the result of that one with the other elements. So we have negative 7 multiplied by 9. Then add that one again with the third element, which is 5 multiplied by 10. Then you need to add space for another element. So we have 5 multiplied by negative 3 plus negative 7 multiplied by negative 3 plus 5 multiplied by negative 9. Then let's proceed now with the other row. We have this one, negative 2 multiplied by negative 1, 3 multiplied by 9, and negative 4 multiplied by 10. We also have negative 2 multiplied by 3, 2 multiplied by 3, 3 multiplied by negative 3, and negative 4 multiplied by negative 9. So performing that, we have negative 2 multiplied by negative 3, negative 1, this should be multiplied by negative 1, plus 3 multiplied by 9, plus negative 4 multiplied by positive 10. Then again, for the other element, we have negative 2 multiplied by negative 3 plus 3 multiplied by negative 3 plus negative 4 multiplied by negative 9. So this is already the uh, practically the answer of our matrix. But however, we need to simplify this one first. So we have to perform the operations that we have here. 5 times negative 1, that is negative 5, plus negative 7 times 9, that is negative 63, so we have minus 63. Then we have plus 5 times 10, that is 50. Then for the other one, we have negative 15, negative 7 times negative 3, that is positive 21. We have negative 9 multiplied by 5, that is negative 45. Then for this one, we have negative 2 times negative 1, that is positive 2, plus 27 minus 40. For this one, we have positive 6 minus 9 plus 36. Now we need to simplify this one again. So we have negative 5 minus 63 plus 50. That is equivalent to negative 18. Then for this one, we have negative 15 plus 21 minus 45. That is equivalent to negative 39. For this one, we have 2 plus 27, that is 29, minus 40, that is equivalent to negative 11. And for the last one, we have 6 minus 9 plus 36, we have positive 33. So this is now the product of our matrices. So those were all the things that we will be discussing in this video. I'll see you on the next video.